Okay, so first of all, I would like to wish you a warm welcome for all the attendees that are with us today. Thank you so much for the head organizer, hi Michael, for organizing this awesome event. And of course, the other awesome speakers that we had today that are sharing their passion and knowledge in our community relentlessly. Today, we're going to talk about one of the crucial topics in the web development, and that is loading web performance. But before we do that, we will take a small step back and ask ourselves why. Asking why is one of the crucial questions that we as an engineers are thinking in a critical way, and we should always ask all of these small questions about stuff that we are doing. Especially if you read a book from Simon Sinek, Start With Why, you know that people who are asking these questions are much more motivated and much more purpose-driven when they are doing something. So if we ask why web performance, and if we Google a little bit about it, we can find information like these and information like these and information like this. I don't know about you, but this seems really compelling to me, really compelling argument. It seems that the users who are experiencing faster web applications are much more likely to stay at your page. Their session duration is much longer. It is much highly likely that they are going to pay something on your website or application. So it's really, really important to have fast web application. So let's go to the loading performance. Why loading performance? So what happens when we go to the URL of our web browser and type the domain of our application? Usually we get index.html from some server, from web server, and that HTML has links to the styles and to the JavaScript files, to the fonts, to the images, videos, or stuff like that. And we fetch those files over the network. But that fetching can be expensive sometimes. And it highly depends on your internet speed, or of the size of those resource files, of the location of the servers, the latency, the request round trip, so how many times we must go to the one server, and of course the user devices. We always have to pay attention that not all users have super fast devices. A little bit about me. Hi, my name is Nikola Mitrovic. I work as a development lead and technical architect at the company called Vega IT, based in Novi Sad, Serbia. And these are the secret shortcuts of loading web performance for you for today. I'm going to jump straight to the point and by saying that the JavaScript is basically the main bottleneck of the slow web apps in today's webs. Large bundle sizes can cause delays with loading of the web applications, with rendering, with the user interaction, even with page scrolling. Basically, it affects all web vitals metrics. And like I said, it's the biggest bottleneck. So we really need to address the bundle size, the amount of JavaScript that we are shipping into the browsers in today's web. If we Google a little bit, of course, or ask ChatGPT about it, what can we do about it, about loading of the JavaScript? We can find information like these. Of course, we can minify the JavaScript or compress them using the tools like gzip or Brotli, but this should be always included in our bundling tools, of course. We could remove the unused code via tree shaking. We could analyze bundle size with Webpack or Wheat cool plugin that is like visually representing our bundle size to us. We could use import cost Visual Studio Code plugin, which will tell us the cost of each import. And we can check the lib size with a really cool website called Bundlephobia. I don't know if you know about it, so I'm going to show it quickly because it's really awesome. So the Bundlephobia is basically the checking the size of NPM packages for you. And let's go with the classic one like Moment.js, because Moment these days is like deprecated and not maintained anymore. And we can see that it's has really large bundle size and it takes really long time to download. What's cool about bundle phobia is also that it gives us the alternatives of the more lightweight libraries that we might use for the same purpose. So really cool stuff. And of course, we can use async and defer attributes for third-party scripts. But one of the most common techniques that we all use is code splitting. So basically, we split that huge bundle of JavaScript that we are loading initially in our web apps into a bunch of smaller ones. And one of the most common techniques in React to do that is route-based code splitting. So let's say we have a Rocket component, which we import in this way. So this import means that it is a static import. And it means that this component will end up as the final bundle of the whole app. And we show it on some route. But what we could do, we could use dynamic import with a lazy attribute. So we can code split that component into a separate bundle. And only once we go to that second page, then we load that bundle. But then again, we can ask a question, what if we do all of this and it's still not enough? What if we have a situation like this? So let's say we have a page like this with 3 separate components. But the thing is that this component is having a performance bottleneck. If we check the network tab, we can confirm that the whole bundle size is in one JS file. If we run a Lighthouse, we will get that the performance is not so good for this application. And if we go to the console, we can see that basically what this component is doing and why it is causing the performance bottleneck is I just wrote all a million times inside of this component. But we want to code split it, right? So we can, if we load this application again, we can see the main bundle. But if we scroll a bit and we start seeing the second section, then we load the bundle of this component, sorry. If we check the Lighthouse in this case, then we're back at 100% of performance. So how did we manage to do this? There is a really cool technique called component-based code splitting. So we can do basically the same step as we did before, but now we have a reference to the second section. And we have this awesome hook called use visible. So when the second section is visible, then we start downloading this third component. Of course, what can we do additionally to this is we can reduce the usage of the libs. So for example, there is even npm package on npm. So probably we don't want to do this. We can do it with one line of code. What is shocking is that it has 200,000 weekly downloads. Shockingly enough, there is odd npm package as well, so we might not need to do this. If you wonder before about that awesome hook use visible, if you thought it is a library or a package, actually it's not. It's our custom code, which is basically just relying on the intersection observer, which is a feature that is provided by our browsers by default. So that is we can achieve this functionality by just using the stuff that we have offered from JavaScript and the browser. We don't have to use a library for it. And in that sense, we can reduce the bundle size of JavaScript. Okay, let's go to images. Again, if we Google a bit, we can find out that we can take advantage of some modern formats. We can use img tag over background image. This is not going to do anything specifically for the performance, but we have more control over an image over background image. So we can create responsive images with source set attribute. We could support resolution switching with sizes attribute. We could load key images with fetch priority. So we load only images that are above the fold, and below the fold, we can use async attribute for that. And of course, we can compress images with some of the tooling that we have online. But then again, like in the previous example, what if we do all of this and it's still not enough? What if we have a situation like this? So we have this picture of a galaxy, which is like a few megabytes in size, and we experience some slowdowns with the internet. So if we reload the page and we observe the network, we can see that this picture is downloading, but you can see that the user experience is not that great, right? So now it's downloaded. Okay, but how can we improve this? We can have an experience like this. So we're still on a slow network, but we loaded the blurry image, the blurry version of an image. And in the background, meanwhile, we're downloading the high resolution image. And we can make this like seamless transition from the blurry image to the high resolution image. So how can we do that? There is a really cool pattern called progressive image loading or low quality image placeholder pattern. In our example, we had that image of a galaxy, which we will change with our custom component called Pro Image, with the source of the high resolution image and fallback for the blurry image. And for the blurry image, if you again thought that it's a package or a component, actually it's our custom code, it's our custom component, and it's really, really easy to create a component like this. How can we do that? We have a state of the high resolution image, and that image is just hidden behind the blurry version of an image. That blurry image is over the real image, and that real image is hidden behind it, and it's downloading the whole time. And when we get when the onload event is triggered, we can hide away the blurry version of an image and then show the high resolution one. So that is how we did this cool pattern. Okay, often we're working with the data, with some APIs, and we're fetching APIs over the network. And how can we optimize this? Is that we can use GraphQL, so the payload is not that much in size. We can prefetch data by using link attribute and by setting a link tag, and by setting a rel attribute to preload. Of course, we can compress additionally those data loads, or we can ask our backend to do pagination and filtering, but sometimes, again, that is not enough. And of course, there is that one additional problem that we are fetching the JavaScript file, the React component over the network. Then browser needs to interpret that, render the component, then figure out which endpoint that we're referring to, then send the request. So this is like additional round trip to the server. So like I said, let's simulate this. So here we have the example of sumirko.rs. Roughly translated to English, this means spaceman. And it's a little bit futuristic app, few thousand years in the future, where which we can use to space travel. But this endpoint is traveling across galaxies, and it takes a lot of time. So it might have a big payload, and it might last quite some time. But if you may notice, I created this little distraction for you while I was talking about the app. That I hovered over the explore link. So that triggered a new request to the API, which will fetch us the all habitable planets around our galaxy, around our planet. And then we can search for where we want to go to the vacation. And let's say this planet TOI 904C, right? Sounds amazing. Always wanted to go to the vacation there. So then we can buy our ticket and go to the vacation. So how did we do this? We can prefetch data with this awesome hook called use SWR. we had that link, which is leading to the next page. And when we hovered over that link, we will trigger a request to the NASA's API with all habitable planets. And then we will call a mutate function from SWR. And there we will put the response in. In our component that is going and iterating through the list of the planets, we're calling use SWR config from the library, and we're retrieving the cache. So once we get the cache by the same key we put it in the previous component, then we can use it, iterate it, and show all the planets. Note that this component with the list of the planets is not doing the actual request to the backend. It's not communicating with the backend. It's only retrieving the list of the planets from the cache that we fetch from the previous page once we hovered over that link. Since we're at caching, HTTP cache eliminates network latency, so we can cache some data and use that version of the data without knowing the changes on the backend. It only affects the safe HTTP methods, and we can control it over some headers. So we have no store, like do not store anything in the cache ever. No cache, meaning that we store some data in the cache, but go to the network and check if there is new data. We can put a timestamp on it, or we can use stale while revalidate pattern, which means that some data after a certain point in time will consider stale and will be fetched from the cache. But in the background, we're checking if there is a new data on the backend. And of course, there is a content addressable storage pattern. So I will quickly show you that. In our one of the previous examples, we had the JavaScript file. That the name of that file was main.something.js. So this hash is basically that pattern. Based on that cache, our browser knows if we have a new version of an app deployed on a web server. But the thing with caching is that it has a limited control. How can we additionally improve this? We can use service workers. So service workers are like a proxy between browser and network. We have more control over cache. Of course, service workers offers us offline capabilities, but of course, some additional performance capabilities since we can have a programmatic control over our cache. And there are these different kind of scenarios with service workers. This is a link that I put in for you. So this is leading to this service worker cookbook GitHub repo, which is like awesome resource for researching and learning additionally about all of these kind of different scenarios when using service workers. So I highly recommend this repo. And of course, we have frameworks and meta frameworks for server-side rendering. So we don't have to do the data fetching on the client. We can do it on the server. So server can go and data fetch stuff for us. Then it serializes into the HTML. Then we get that HTML version into our browsers. And after that, we do hydration. So basically, we are streaming the JavaScript for that HTML that was server-side rendered. So we know how to handle interactions of those elements. And of course, these days in React community, there are some popular frameworks like Next and Remix, which have some similar features. Of course, they have a lot of different ones, but we would probably need a special talk only for that. But in general, why those frameworks are so cool is because of the concept called edge computing. So edge computing is like a CDN for data fetching. So if we have a server that is fetching the data for us, no matter if we are using CDN for web application, we would still need to have to go to this server for data fetching. But with edge computing, it's like distributed across the globe because these frameworks are automatically converting our app into Lambda functions. So it's all distributed. And in that sense, we reduce the latency and we deliver our components to our clients, which are closest to us geographically. And of course, we have this all of cool idea that we have a 0 kilobyte JavaScript, and we can do that with the frameworks like Quick or Astro, where we initially load 0 kilobytes of JavaScript, which means that the performance will be automatically 100. And then we are using pull mechanism to just pull the code that we want on interaction. And of course, with Astro, it's like this kind of island architecture where every little component is like independent of each other with loading. And of course, we have React Server components, which is basically the concept of the data fetching, that some components are on the back end. They are doing the data fetching. They are just streaming those data on the client. And for the end, we saved the best performance hack ever for you. Ready or not, here it comes. So we can just put 5-second delay behind every common action in our software. And after some time, when users go crazy and our manager goes crazy, then we just remove those timers and everybody will love us. We will get a raise, we will get a promotion and everything we want. For more advices like this, please follow me on LinkedIn or on my other socials. Of course, I'm kidding. Please don't do this. This was just a joke. We should be professional and approach the web performance as professionals. So basically, yeah, that's it. That's all from me for today. Thank you so much for being here. This is my email, so you can find me. And if you want to discuss about performance stuff more, I really love to talk about it. And this is the QR code to the slides. If you want like a refresher and go through the slides again. And this is my GitHub where all of these examples that we covered today are there, so you can download them and check these results for yourself. So yeah, that would be all. Thank you.